So, and I don't see you. You need to join. And there you are. Oh. Basically, I'm on mute, and it should all be going through you, so you'll be seeing. Not many of us here, but yeah, it is what it is. We're a small but passionate group. Yeah.
And incredibly good looking.
You got it.
Can't see it.
So, maybe some people will see this online, and who knows? Usually we get, some people watching it online anyways. Eventually, I think the last one got over 100 views. I know that, what's his name? Ken Cousins got like a few hundred views, but obviously it's Ken Cousins, so. But anyways, basically I'd just like to thank Nielsen for, sponsoring us with food and beverage. Even though, they're out there, they'll come back. And just make my general pitch of, we need speakers. Because that's what's killing us right now is we don't have enough, we don't have a pipeline period of speakers. It's like, so if you have a plugin, a library, an experience that's Groovy, Grails, Spring Boot related that you would be willing to talk about, come see me or talk to me, and we can set something up. You don't have to be Ken Cousin or Bert Beckwith or anyone like that. So. Let me know. Thank you. And I'll turn it over to Jan.
Well, thank you again for the invitation. I think this is now the second.
Yeah, this is your second
time in about a year. In July, I think last year, we talked about scientific applications of Jenkins, and we'll be talking about something a little different today, more around things that everybody should be familiar with. So I want to start with a little story from ancient Greece. I am from Greece, by the way. I arrived here when I finished high school there and spent the rest of my life here. But nonetheless, what was one of the most famous cities in ancient Greece?
Athens.
Athens, wonderful. So the Athenians were, of course, very famous for their philosophy and their having time to sit around and shoot the breeze while the slaves were doing a lot of the work. And of course, a lot of the big philosophers and so on came from Athens. And of course, Athens was dedicated to goddess Athena, who was among the Olympian gods, the goddess of wisdom. Okay? And war. So you were not that far off. So if you see a statue of Athena, she's holding a shield and a spear on one hand, but what is usually on her shoulder? It's not a parrot. It is a bird, though. It is an owl. An owl was considered the bird of wisdom. So, when the Athenians would see some foreigner coming into Athens and engaging in their philosophical discussions and so on, they would say somewhat jokingly to each other, and probably, anyway, looking down at this person, that he was bringing owls into Athens. Because, of course, they had all the owls. They didn't need any more owls. They had all their wisdom. Mm-hmm. So maybe I'm bringing an owl into Athens tonight. You guys are all developers. You understand languages and probably Groovy, since we're in a Groovy group. But I have worked with Groovy probably for close to 10 years now, on and off. And it was a kind of breath of fresh air 10 years ago when it appeared, and we're all programming Java at the time, and all of a sudden now we had this new power of collections and closures and so on in our hands. Now with the release of Java 8, finally Java is sort of catching up with what Groovy used to do 10 years ago. That doesn't mean Groovy is obsolete, of course, in any way, shape, or form. But I just wanted to just touch base back with you to see the kind of things that I have been using Groovy, and specifically collections that we're going to be talking about tonight. Some of it may be introductory for those that may not have used Groovy recently, or just a reminder perhaps of some of the interesting methods, the API and so on. And then I'm going to give some examples of what I do day to day. I work for a pharmaceutical company in Cambridge. By training, I'm a biochemist and cell biologist. I also hold a degree in software engineering, and for the last 15 years, I've been doing mostly data management, data analysis, image analysis, and all kinds of other interesting things that happen in the space of drug discovery. My company is working on it. So, hopefully something useful will come out of this discussion. So, you can allow my owl to sit in the presence of all of you wise Athenians. And we'll go from there. So,
I think you have to share desktop.
let me do that.
You're still on that camera. On the left. Second one. Second there. Yeah.
Okay. So that should allow us to go here.
Yeah.
Can you tell?
Yep. All right. It's working.
Good. So, just for our talk today, I created a small repository, and if you click on this collection here, get to the short presentation that I put together, and here's some example files and scripts we're going to try to use. Okay. All right, so already I talked to you a little bit about where I work, my background. I'm primarily contributing to open source projects. The biouno.org, sort of closer to my heart. It's something that we've started with a couple other people that are interested in using Jenkins for scientific workflows and applications. I have actually taught graduate level courses at Brandeis in the bioinformatics program. I have taught some Groovy programming for non-programmers, people in the lab that I work with. Occasionally I blog, and that's sort of in summary who I am. Okay. So what was driving the Groovy collection design 10 years ago? The focus was on what the code does, and walking away from how we used to do things in Java, which was how we have to set up an iterator to do things, count and all that stuff. So this is more like the idea behind the Groovy collection design was more to make them like SQL-like. Right? You don't tell the database how to execute the query plan. You just tell it what you want, and you go ahead and figure out what things to do. And essentially that reduces the team using the collections as data structures. Now the Groovy collection, it comes from two separate lineages. Ranges themselves were new, and they did not exist in Java at the time, and they still don't exist, but you can sort of simulate them. On the other hand, the lists and the maps, they are coming from the Java collections JDK, and therefore they inherit all of those methods and properties that lists and maps have in Java, but at the same time, they're enriched with a whole bunch of new methods that the JDK adds on top of them. So I'm going to briefly go through the three major types of collections. We'll talk generally what they do, what is interesting about them, and then we'll show a little bit of action with some code. So ranges, as we said, they were new in Groovy. They didn't exist in Java. And they can be actually of any data type as long as the type itself implements three methods: comparable, next, and previous. So you can have actually date ranges or string ranges, object ranges themselves, and of course, a lot of the things that we're really used to are the integer type ranges, right? From one number to another number. These are objects themselves. They can be passed around, and also they can be used as grep filters and switch cases, which we'll show some examples of that, because that makes actually logic flow quite interesting by using these ranges and other objects as logic switches. So when we want to define arrays, basically we include a starting point, the low point of the range, and then two dots in the high point of the range. Or if you want to not include the high point, you can include this kind of nomenclature as you see here. So let's see if we can go to some code.
You might have to change to share your desktop though. You're going to go outside of this.
Yeah,
rather than
let me just.
May I suggest you share the
the desktop.
desktop?
Yeah,
You
so
need to go back into the Cool Hangouts tab. Yeah. Click on the.
On this again.
And this way you don't have to constantly switch.
yeah,
And then instead of clicking in,
Yep.
and then
The
entire screen.
entire screen.
screen,
Okay.
yeah.
Thank you.
Yep.
So basically, you can define a range, something as simple as saying, you know, I want to start from 2 and go to 10, right? Or, and you can of course give it now a name and pass it around. Right, so that's sort of, you know, just on the definition side. And then you can have another range where you can be starting, let's say, from 2, but not necessarily including the 10. Some of that I can only see there, not my screen, because of my glasses. Okay, so let's actually dive a little bit into some of the simpler methods of the collections that were really powerful when they came out and still are. So some of those are methods that allows us to iterate over the collection, and that would be something like each. So we can say each. And now, of course, we have here what is known in Groovy as a closer, which is essentially an anonymous method function that we can act on each element of the collection. So let's say that we wanted to just print the double of each one of these elements for range 1. Now,
Oh, can you increase the size of your
Yeah, increase the
It's
font.
pretty hard to see it on the
Yeah, like
somebody-
View.
yeah, it's under view somewhere.
So
Large
large is all.
Large font, Control Shift L. Control Shift L. There you go.
No, it's too big.
No, it's not.
okay, I even can see that in my. Okay,
Yeah, that might help.
very good.
Unfortunately, the AC is off and it's not controlled. It's turn off a bit. I think some other room in this office had AC on, but I'm not sure. Well, check that out.
We'll survive. If there's a way to turn it on.
I'm not sweating yet.
All right, so at this point we can run this small script, okay? And of course we started with range 1, right? And so we got the multiply by 2 each one of those elements, and we can print them over here. And if we decide to do range 2, we should only get up to 18. So that's one of the simplest uses of how collections were became quite popular, because it was so easy to iterate over them and actually do something with them. All right, so the next thing we're going to talk about is actually lists. Now lists are of course.
I have a question.
Sure.
What would a range of strings be?
So a range of strings, it has a default thing. So you can say from A to Z, right? And we can go back to that, right? So let's say actually that this one was.
Are those characters or strings?
It would be. Well, it understands characters, right? So if we have something like.
Nothing cool like aardvark is settling.
I doubt it. What do you think the output will be for this?
Question, because you're multiplying by 2.
You multiply by 2, and of course, Groovy can do that.
Yeah.
Right? So you get this.
Right.
All right. So multiplication actually exists on this. Now, if we had.
Because a string doesn't have an X.
Right.
Right.
Now, on the other hand, guess what has next in enums too? So we can say that R2 That's correct. I don't know if I'm defining the enums correctly here, but that's capital anyway. I don't know if the class actually.
So if you had an
So
enum class, it could
yeah.
probably iterate
Yeah,
over.
I don't know whether I need to import it or not.
values.
Is that enum?
Just
Yeah, maybe that's what it is. Let's try that.
Probably not.
Hmm?
I mean, this is kind of
Anything that has the so actually this needs to be imported, or maybe I have it.
yeah. That's what I was saying. It's just a class that isn't
Right.
Yeah.
as opposed to a variable.
So yeah, we may need to define that.
Yeah.
This is the class, right?
Yeah, I think it's so low.
Oh, yeah. Okay, I don't know exactly the correct syntax now. How to
They
put it
just shouldn't have a quotes around
Yeah.
tokens, not strings.
Yes, that's right.
Alternative syntax.
Yeah, I thought it was more like a string array, but it was not.
We're getting different exceptions in this practice.
All right, let me not waste your time, but
Yeah.
I know that enums can be used as a range because they
Using
do
it directly like
they,
this.
they do
E
implement.
dot each. Just use E dot each instead of R2 dot each.
You can, but then that is not so much of a range, right?
It's not range.
Yeah, it's not iterating over the range.
The question is how to create the range from
Yeah.
Yeah.
enums.
You can try E and E
That's all.
yet. Just try values.
You know,
And E.
Because we didn't actually define a object. This is just a class, right? Something like that.
No, no, yeah,
It's me, it's B.
Oh, yeah.
And you lost
Oh.
tokens.
Open, right?
Okay. So something actually also is erroring out here, though, right? It's a line.
Sure.
It doesn't
The
like
first-
assignment.
Doesn't like the what?
Assignment, yeah. You cannot E equal to E. Yeah.
There's no assignment.
Yeah, enum is just
No, just
declaration of
class.
the
Yeah.
class.
Yeah, just try instead of use first, last, use actual value.
E dot and E dot.
em.and to em.end.
Instead of first and last.
No,
Yes. All right, we struggled together, and there we are. Okay, so it implements the first, last, and comparable, so you can do that.
You might be able to do min and max, min value and max value. That might be another way to get at it.
Of course, you can always just iterate over the values as well. But
Well,
Right. I mean, if it was a
sub-range,
right.
not from the
Right.
first,
So you
not
can start
to
at
the
the second in the.
but still
yeah.
going in the order, which again Java suggested not to rely on.
so presumably we could even do like what we did before, right? By excluding, maybe you only get 2 out.
That's cool. I didn't know about the less than sign. Learned something new.
So lists. So of course lists are from the heritage of Java. And they inherit properties and methods from both the JDK, the list interface, as well as the Groovy DK, both from the object and the collection interface.
You just go full screen.
What's that?
Full screen.
Full screen.
Oh,
present.
Yeah. Okay. Do you get an air conditioning draft over there? Is that why you're standing on it? So, but there's some really cool things about the list. Of course, we create lists with integer subscripts.
conscious and subconscious.
And they have append, plus, minus, and multiply operators in those. And of course, also the equal operator, where you can actually compare two lists. In terms of the, so these are in terms of defining the lists and some of the operators. In terms of the methods, there is a multitude of methods for manipulating the list content, adding and removing elements, combining the lists, sorting, reversing them, flattening them if they are nested, remove duplicates, transform. So they are very, very powerful. In fact, I'm going to show a little example where we can start using some of these methods to almost like build a mini database system where, you know, instead of SQL, we can use Groovy method calls to filter things. And then, of course, they have a variety of methods for accessing the list content, query, iterate, and if those are things that you can accumulate results, such as getting the sum, the max, the min, grouping, and so on, you can do that as well. Okay. So let's go to look at some examples from this we have here. Is it coming up?
It's only turned off in this.
Of course.
All right. So one of my favorite ways for creating lists is to actually provide a comma delimited list of things and start from there as a variable, because otherwise it's a little hard to type this. So we can define something that is a comma separate list, and I work with these kind of things a lot. A lot of the scientific data comes as comma separated values, and so headers from where you want to understand what the columns are, values that you want to filter and extract. A lot of these data is already coming in comma separate lists, and of course, you know, you can read it in, and then we can work with it and create lists. So one of the simpler ways to create a list is to simply pass in a string that has I don't want to do that.
Yes. Yeah.
So you can define lists simply as, well, you see what the issue is here. Here, in order to define this list, you had to put quotation marks around it and so on, right? What I wanted to show you is a simpler way, which involves the creation from a comma separate list. Right, so you just have a comma separate list. And you can very easily create a list from this by splitting this list along the commas, right? So now we're going to create a, which is something as simple as that. Right, and now we see here the outcome here. Now, it is likely that this has now some white space there, right? So can we very easily introduce a new method on top of that, just to make sure that we remove that. So basically, what we want to do is trim each one of the values in the list from a white space. Right, so this first thing here, we'll create a list, and then we iterate over each one of those, and we get the list without any spaces. Although, you know, for the pretty print of Groovy, it looks like there is space there, but in fact there is not. And that's important sometimes to make sure that you remove the white space.
Is that actually working? I think that might be actually just iterating over the values and trimming the values, but not assigning those values, not returning those values.
Well,
Which is
you
the
could
last
do a
thing.
print.
Yeah, so you can actually say return list. That's the list, right? If you don't have a return, it's the last sort of value that it was calculated there.
Can we
But I
do
think you
list
need collapse.
each, print
Sure.
it, and in quotes, so we see how what the space are.
So in fact, this is a good time to show a transformation method of lists. It's called collect, right? Because you wanted to put the quotation marks around it.
No,
So
I
that
just
we
want
can-
to print with the quotation
Yeah,
marks. I
but
don't want to put
it's-
it there.
Just as the
Right. So we're going to take the a quotation mark, add it to the value, and then add another one.
Plus instead of equal.
All right, and so that should be the last thing that is returned.
And it has the spaces.
And it has the spaces.
So you should use collect instead of each.
Yeah. So we can do actually an all in one step then. Because we didn't collect it into anything, right? Before we're just trimming it, but we're not doing anything. So now we can trim it.
What happens if you just call trim on the result of split? I actually don't know if that'll work, but
You can.
it doesn't work.
What about dot star?
Yeah.
Sorry, you might be able to spread it overall.
Spread it.
Split is a string. String.
Yes.
Trim.
But then he returns a list, and then you got to, I think the method trim is on a string, right?
So does it return this list or array? Because in Java split returns an array.
The split is a list.
Okay.
Yeah.
Okay.
Madness.
I mean, okay.
But the spread should work.
Yeah, sure.
Yeah, there's a spread operator.
Let's try the spread.
Right on my wife's too. She'd be very
So that would be this, and then that. That's how it is. So that this spread operator works just. All right. So. All right, so I don't have to talk about the spread operator. I wasn't planning on talking about it because I don't use it a lot, but yeah, I do use collect a lot. In fact, I'll show you some statistics of the kind of things that I'm using. They're probably embarrassing because it shows you, the simplicity of things that I'm doing. Okay, so all right, let's do a couple other things on this list while we have it. Let's work on some of the useful operators that exist on it, right? So let's assign these to a new list.
Yeah, you can call trim on the spread if you use the spread operator.
You can.
Yeah.
Yeah.
Right.
So
Which is
just run.
being run on a list.
It's not on the list.
It's on
It's
each
a spread
element.
operator, so it's run on each element of the list.
Okay.
Yeah.
Sure.
Okay, that's good.
The point being, you don't need collect to do it.
Right. So either way, even if you don't use the collect, you can use the trim.
Getting dangerously low code.
Well, isn't the spread operator not necessary anymore?
It's one that I don't use often. It's
Can you just do me a favor? Can you take that spread operator out of there and see what happens?
Okay.
I just like to experiment sometimes.
we had an exception.
Exception.
Because it's just a method on a list. It doesn't exist.
I don't use the spread operator anymore, so I guess the stuff I'm using doesn't
I
require it.
just keep forgetting it exists.
We can also iterate over this in reverse by using each reverse.
Oh. Didn't know that existed.
We're getting an exception.
Just reverse, not each. So use just reverse without each.
Just reverse.
What is it reverse each? Maybe it's reverse each. That's the way it is.
Reverse each. Yeah.
Reverse each. All right, so we got the reverse printout here. Well, this is the actual value of the list. All right, how do we add elements to this list, right? There are a couple of different ways. The one is just like this, the assignment operator or append. All right, and the other one, of course, is through the method add. All right, and so of course we're looking at the last result here. That was what was added. We can have and we can take elements off the list.
Can you use plus there, list two?
Yes, I was going to show you now the actual plus and minus overloaded operators. You can say list 2 minus
Well,
yeah, because it didn't change. Well,
Yeah, because it's returning a new list, which is
Right.
list 2 minus time.
Exactly.
So you have to have
Here's-
list 2 equals list 2 minus time. or
Set it to
minus
list
equals-
3, list, and then return list 3. Yeah, that. There we go.
assign it to it. And of course, you can use the plus. And you saw what happened with the multiply also, right? You will add two of those elements. Now, when you're doing sort of, bioinformatics, set analysis comes in quite frequently. And, the ability to combine lists and, find intersection, uniqueness, and so on, all of that is very important. And it does exist in the API, right? So let's say that we were adding another time here. And so we have time now twice, but we can say unique. That will give us the unique set of the elements in the list. All right, and we can also sort them simply by, actually, it's, right, so we can get them in alphabetical sorted order. So it's pretty cool being able to add, one method after the other, chaining them and getting what you want. Okay, let's go back to the presentation see what we have here.
Isn't there some issue with some of these methods changing the underlying connections, collections?
So you got to be careful because these are still Java collections underneath, right? And the same issues that exist with synchronizing, the modifications and so on exist there.
But doesn't unique actually change the collection that you call them?
I'm not sure.
I think it does.
Yes, it does.
There's a flag.
It does create,
say-
it does change.
Modifies the list.
There's a flag that say don't.
Oh, it modifies the
But
list.
there is another one that takes the use case to.
Yeah, it true or false there, and you can tell what
Because not all of them do change the underlying connection, but I know
Not
that
all
unique
of them.
does.
Each dozen collect dozens. Yeah, it depends on which one to use. That's why it's good to look up the Groovy GPK. Because you can find all these methods there, and I find new ones every once in a while. It's like, who do I do that?
Yeah. So at the end, actually, I have a reference there, so you
Yes.
guys can go to the both the Groovy collection, and here's the actual API. Right. So get over that. Yeah, there's so many methods to do this. Right. You use just a handful of these things.
I try to sometimes print all the possible methods that the object comes in, so that I can see what I can, and that's with
Yeah, and Groovy that
Meta-
could be a little, with
Meta class.
Yeah, you can get at it. But that could be a lot with Groovy.
With Groovy, you can just call dot properties.
Yeah.
You could do that.
Returns
Well,
a
that'll give you the properties.
dot properties will return,
A map of all the properties.
So
of
the
the
properties, but not the.
but not the method.
Right.
It's talking
Right,
about
not the
printing out.
behavior.
Yes.
Oh, okay.
Right.
Yeah.
And also
So-
you might
yeah.
surprise of some properties which you didn't define.
Right, sure.
Groovy add them.
Class.
Oh, yeah.
So, think about it. It's like your cable TV. You have, hundreds and hundreds of channels. And how many do you actually, watch, right? So I had actually that question. So I did a little bit of an experiment for this meeting. What I ended up doing is, I'm going to show you that now since we're kind of, talking about this. I went through and did a little analysis of the methods, of the collection methods that I've been using for the last 5-6 years. Okay? So, I have a couple hundred pieces of code between these Groovy scriptlets for I use Jenkins a lot and actual scripts. And you can see some of the methods. Each, you use it a lot, and join and each with index. And there are some other things that are quite useful, but don't use them a lot. And certainly, if you look at this, it's like maybe 10, 15 methods that I've been using on and off in different contexts, but are not necessarily, not even like maybe
Right.
20% of the whole JDK.
Right.
So it's whatever you feel comfortable with, and you find practical. You apply it, you know it well, and you use it. Yep. Any comments on this?
No, but there is one that I think of off the top of my head that I use more recently is find results.
Find results, yeah.
'Cause that's an interesting.
I think
Yeah, I
have.
don't know if you have an example later on, but that one's an interesting one to look at.
There's one that I forget the name of, but it turns allows you to create a map from a collection of objects.
I think it's still collect, but you have to create the resulting object in some fancy way. So if it's a special type of,
No, there's another method. I'll look it up.
Yeah, but you can have, as long as you have an object, right, that has sort of properties, you can pass it sometimes either to list or to map, and there's some interesting transformations happen there. Yeah, so, but for my work, a lot of it is actually scripting. So I don't develop a lot of sort of fully fleshed out classes and objects and things. So certainly this is not representative of the kind of things that somebody that's developing a library, for example, would be dealing with.
You're right. It does start with collect, but it's collect entries.
Yeah.
So it's smart enough to realize that collection of entries is a map.
Yeah.
Yeah. So yeah, I just I was interested to see, okay, so I've been using all these things. I'm going to be talking about them. Let's see, what is my knowledge? What kind of owl am I bringing?
So I found find all pretty useful things when you filtering the collection into the smaller collection by criteria. Find all. I see you don't use that.
It's on the left.
Yeah, for those things I haven't used it. So
Here you do.
Yeah, but like I mentioned, find results. One of the things that does is it won't include null values.
right.
That's one of the key ones to that.
Null values.
No.
Yeah. So
So you don't have
if
to call
you have something that returns null, it won't include it in the end result.
And that's what grep does. But I guess you wouldn't have to call it grep then.
You're using it in the closure. You're using find.
Yeah.
In the closure.
Yeah, and basically whatever the result is, as long as it's not null, it'll include it in the final result set.
So does it have find or find all?
Find will return the first one.
Yeah.
Well, find, but find all, you're just asking for explicitly what you're trying to do. If you say IT dot something equals something, it returns null, that's not going to be part of the return collection. So
Well,
I guess it depends
that-
on
that
what you put in your
depends.
closure.
No. So find all will just the closure just return you the true or false to include element or not. So if element is null and it's returned, no. If your condition
numbers
zeros.
no, your condition. If your condition on the null value will return true, it should include that. The question if collection can handle that.
So what if you have just that
Stopping. That's what it is. It stops once the first non-null result is found.
Fine.
That's really interesting. So it skips null values.
But there's find result, but there's also find results. That was the one I was talking about.
Right.
Because there is a distinction between the
Yes,
two.
there is. So the find result brings you the first one again.
Yeah.
And find results brings them all.
So where is the find results?
What is it? I don't know. That's an interesting question. Why it's dropped out of here. And I have seen it in documentation, but for some reason.
Oh, it's
Unless it's specifically,
it's one of the inherited ones. It's from a collection. So it's inherited from the collection.
From the object, I think.
No, from
collection. If you scroll down, to the section of
Oh,
the
you're on
inherited.
collection.
I am on collection.
Because I'm on list and it says it comes from collection. Inherited from interface Java util collection, but it's obviously the upgraded collection.
What version are you looking
Oh yeah, that could be too. I'm looking at latest.
Well, this should be
He's
the
looking
latest
at
too.
latest.
Yeah.
Java util collection, so it should be in there somewhere. Just,
You can
Do a
just search.
for it.
do a search, yeah.
That's how I find it. So we say find
We should do it the Groovy way.
results.
Yeah.
And there's,
Yeah, there it
oh,
is.
it's
From
just
iterable.
We should do it the Groovy way, which is have Groovy get the HTML from the page and then search for it that way. You'd have gotten extra points for that.
Right.
All right.
All right, I think that's, that would basically, list gets it from collection, which gets it from iterable. Or something, that, because it
Yeah,
shows it, I can see it in both right now. Anyways, it gets it from somewhere, I know.
It is there. This is most. And if you go to iterable, it will inherit it from somewhere else. Probably not. Probably not.
Object.
Yeah.
It does make sense to find an object.
All right. So. So maps, actually maps are very similar to lists overall, right? The only difference is that the subscript that a map can take can be something other than an integer, which is usually in a list, and you can have actually any kind of object as a arbitrary type of a subscript. Right. So let's see what else we have here. Okay, I was going to talk a little bit about closures, but obviously I don't need to. You guys know exactly what closures, because of course they come through as the type of thing that you apply on the methods. So everybody needs to understand what a closure is, and of course we use the implicit variable it. When we're working with collection closures typically. But if you were working with a map and you want to work both on the key and the value, of course you will define specific key value parameters for the closure, and you can use them both.
Do closures execute at runtime? They compile at runtime?
I don't understand the question. What do you mean?
Are closures compiled during compile time or at runtime? It's during
They
compile
compile,
time, or is it a runtime compilation?
They're compiled,
Because it's data, right? You're treating code as data.
you are, but it's kind of like,
It just
it's kind of like an
And so that data
it
can
just
change.
created a class underneath which has one method.
But that data can change during runtime, so that's why I'm asking that.
But it will
Which
be
data?
executed at runtime, yeah.
Yes, which data changed? The parameters changed. Yes.
Well, yeah, but
and
the
you can, if you have a closure, one of the things I know you can do, like if you do static compile, you can't use it, you have to explicitly give it like the name and the type of the variable you're sending it, so you can statically compile.
okay.
So I would assume that it's definitely compiled, because it makes an anonymous inner class is how it deals with it, essentially, under the covers. And I think that don't streams do something similar as well under the covers. I don't remember all.
I have a question about your last slide.
Or Lambdas.
So
I'm sorry.
I
Yeah, go ahead.
just want
Finish up,
to
yeah.
finish that. So it's basically, you can think about that as, for example, comparator. So you create the comparator, just the class around that created for you, and you pass it into the find or find all. So it is a code which is compiled and it is executed in the context when you're running this thing. So. Sorry.
So I think on the last slide you talked
On
about
the map?
maps. Yeah, maps being able to be referenced by subscripts.
Right.
Like what? Do you mean index? Or I'm not sure what you mean by that.
All right. So yeah, let's see a couple examples of map. But essentially, you have a key value here, right? And you're referring to the key in the map. That's now a string, right?
Uh-huh.
But you could be referring to an object rather than a string.
Okay.
So the map can have an object as a key essentially, right? That's all.
Because I know that maps, if you just define a map in Groovy, it's actually a linked hash map. So they retain their insertion order.
They do.
Yeah.
Yeah.
So I thought you were talking about index, pointing to the position of the entry.
No, I mean, I'm talking specifically how you recover value from the map, right? In the list, you say, give me the second element, right? Here, you say, give me the element name.
Can you take the second element out of map?
Apparently, with Groovy maps, you can't because they are still ordered. But that's, I think, only if you create them, by adding elements. If they are like created out of, I don't know, some operation, they might not have an order. So you don't know what the second element is. I mean, you might still get it by referencing it.
I mean, if it's just a Java map, then it's different from a Groovy map. But I thought Groovy maps were linked hash maps under the covers.
But in terms of how you retrieve the value and knowing what you're retrieving, that's the real gist of it, right? Because if you don't know what you're retrieving by a numerical index, right? What is that to you, right? You want to say something?
No, I mean, you probably shouldn't ever call it by index a linked hash map, just for performance. But if you wanted to, I guess you could.
If it's list hash map, then performance should be bad because list is actually array list.
Right.
So you can address them by index anyway.
But I think they're linked.
The question is if from some operator which return you the map, it won't return you a linked hash map. Right? Will return you some hash map, for example.
Right.
Because there is no order in original things. Then this by index would give you the random.
All right, so actually we talked about iteration. We went through this. And here are some of the find methods that exist on the collections. And these methods take a closure, and if an element matches the condition, then we get back the result. And I think we looked at this. So when you have the without the all or without the plural, you get usually the first one that's returned. Otherwise, you get a new collection with the results that all match.
So find index values. Is it instead of find indexes?
So this is for it returns you the index in a list typically, right? By matching the value.
So it's
right?
return use a list of indexes.
It returns, and this actually to me it's the weirdest one of all because it returns a list of longs, right? And it has, then you expect that you're going to take that index, put it into an array, you're going to get the value back, and it doesn't work, throws you an error, right? So, nice. So, I've posted that actually on Stack Overflow.
Why? Did you figure out why?
No one knows why, but I think by now enough people know that you have to cast it into
I can speculate.
integer.
Sure.
I don't know, but I can speculate. So if you have a map which has a long as a key, then this would also work and return you you said long or double? Long. Yeah. So again, this would be speculation.
When you talk about an index, you talk about.
Yeah, but if it's the integer number, and they might just think about this long as so you have just a few indexes, not the full array of indexes because you have a keys as a long, so you can use that. I don't know if they try to do some funny things about that. So this is might be why they return longs. But yeah, I agree with you. It's strange.
So I think we have a small script demonstrate that. So here's my. All right, we talked about transformation of collections. Right, and we actually saw that. I mean, how many of you use Groovy console as a reference for sharing, some little scripts here and there? For my classes that I teach people with, I use it. It's a kind of a love-hate relationship with this tool, but nonetheless, it's good for a quick demo. So I think we've seen some of these capabilities before, but nonetheless, let's just quickly. So here's the collect method with an additional collection introduced into it. So you can actually collect the result of the transformation into that collection. Right. So so when we execute this script, we're working off a Groovy range, right? And we essentially perform a transformation on it, which is, we're going to multiply by 2, and then we're putting it into this collector that we pass it into the method. And then, of course, when we looked at here, it returns these values. So this is an example where you can flip the key value pairs in a map around. Right. So here is a simple map. We collect the entries and then we put them into a new map. But basically we flip it around, and now we have.
The map becomes the key, and
Exactly.
the value becomes the key, and the key
becomes the value. Right. So it's these are pretty cool ways to transform things with collect entries or with collect, and they're quite powerful when you're processing data and
So what's the difference between the last 2 examples? One, you have a value comma key. Another, you have a value colon key.
Well, when you do the colon, right, you are essentially doing a map over here. Right, so this is.
But the result is the same. Or at least it
No,
looks
I
like.
think he means the colon over there. Yeah, where here you're doing a map. And
well, this
there
is a map. You start with a map, right?
No, the one below it.
That's an extension of that.
That goes from here, right?
Yeah.
Right. So in the line above that, you put in square brackets value comma key. In the last line, you have in square brackets whatever the value multiplied by 10 colon key to uppercase. So what's the difference between comma and colon?
Yeah, this
is because here you define the map, right? The map has 2 elements.
But doesn't matter.
But
So you define it
but at the end, it looks like
In the
the same
value
map.
times
For
10.
quality, it doesn't matter.
because
That's
this
what you have.
it iterates over these two, right? It will iterate over these two, so it will create a new map with two elements, which again, you know, when you want to check for equality, you're gonna have to write it out there like that. Right? Yeah. That's all.
Oh, I see. Well, so, right, but there's two different nomenclatures. One is the line before it, what he's saying is that value comma key.
It's a list of 2 elements.
So
And then the
one
second
collects
one.
lists, another collects map elements.
Yeah.
But
Maps.
for result, it doesn't.
Okay.
both collect.
But when collected, apparently, it creates the same kind of map.
Right, because, well, no, right, because here,
So it interpreted two elements in the list as a key.
two
and
elements
value.
in the list versus the.
What if the
Versus
list
a map with 12 elements.
In here, it's either
I
a
know.
map entry
Yeah.
or two values, key, comma, value. So it can do either, and that's in the documentation.
Oh,
I don't know why. that
so
is.
there is two nomenclatures for.
Yeah, you
two-
can do.
two
But
ways.
you cannot put
Two-
3 elements in the list. It must be
No.
2 elements.
Must be two.
Must be two.
Because it's key, comma, value. So it's either key, comma, value or map entry. So that's
Yeah.
key, comma, value, and that's map entry.
But the result is the same.
Because in the
Yes.
first case, if you just put value, comma, key, value will be not a value, but literal value as a key.
You could you replace that colon with a comma? Right
Here?
there, yeah,
Yeah,
Yeah, probably.
sure.
and it should work.
But in the first case, you cannot do it.
Let's try to do that.
Yeah.
And you also change the previous line.
We'll do one change at a
Yeah.
time.
One change, one change.
One change at a
One
time.
change. Let's,
Don't
Don't break
All
two
right.
things.
Just that.
Just break one thing at a time.
oh,
I think you lost.
yeah, you just gotta
Last one.
So the last one
edit in
was,
console.
On to the comma.
Okay.
Edit in console.
Yeah, you're not.
You gotta,
yeah, that's
uh-oh,
part of my log
uh-oh.
relationship.
You were saying that when it's just switching them around, that the key and value are staying as key value
let's-
objects. But, so is the key,
So when you have a map, the first element, if it's not quoted, like it's literally be interpreted as a string length. So that's why if you put just one value, it will be not the value of value argument, but this is the value. The key will be still the value.
All right, so we're gonna execute.
No such
Oh,
property.
okay, this is up here. That's types.
Oh,
Yeah,
okay.
let's delete that.
All right.
It wasn't there before.
But we'll
Yeah, well, they're asserts, so.
there's only
Yeah,
just
so it's
Yeah,
a
it's
pass,
true.
right?
Okay, what about the first comma? In
So
here?
That
it's
one
passing.
will break.
Which one?
Let's see.
If you turn
Yes,
it-
in
turn
that
that
line.
one
No,
over.
not this one. In the square brackets.
In this
No,
one,
same
right?
line. The second one. Here.
Yeah.
And
Here.
here,
Yes.
right.
The column.
But I think there is a way to get that to work
you can put.
So let's see
Parentheses,
the
yeah,
results.
around the value.
Insertion.
See, the result is value as a key.
Yes.
As a
Yeah,
string.
yes.
But if you put parentheses
Yeah, yeah.
around that value,
Yeah.
then you can
Yes.
do this.
Right. Yeah.
It took me a while to figure out the parentheses.
Yeah, so
inside
that
because
one is like, I don't even
it's-
know that, but I'll always send this back.
So will parentheses works
Yeah.
in my case where I use
Yeah, they're
quotes
passing.
or
We'll talk later because I don't know.
I showed you and you used that.
What,
With,
really? Yeah.
Okay, we will do.
Yeah,
Okay,
I-
later, context switching, I'm lost.
Okay.
All right, so,
So using the colon, you don't need.
Yeah, that's why we have a list as a return, like the avoid putting this parentheses.
Yeah, so you don't have to do that extra.
all right, so obviously we're not going to go through the entire API, and you guys are familiar with some of these. I'm just going to show you a few examples of how I've used some of these things in the context of my work. So the first thing, as I said, I did was to create this sort of statistics here, and you know, we said it's probably much more complicated, and this nonetheless, you know, these are the methods that I commonly use. As I said, I spend a lot of time with delimited files that I transform, I filter, I need to reformat and so on. So some of these come really, really handy, such as joining, because joining allows you to take a list and join it into a string with whatever delimiter you want. And of course, if you use comma, you have a nicely comma delimited row that you can put into write out to a file.
So it concatenates?
Yes, yes. So it will concatenate that.
So how you come up with the statistics? How you actually found what?
I grab my code.
Just by patterns?
Yes.
So if you have a comment which has an each in it,
right?
Did you count that or not?
If I have a what?
Comment.
Comment.
Or strings literal.
He doesn't comment yet.
So
I'm still using it.
So my grep tool does show me the matches, and
Okay.
I think these are true.
Okay.
But
No,
nonetheless,
I just curious.
Yeah.
It's interesting statistics.
You're a stickler.
Yeah.
Yeah, and I work with it.
Every day.
Well, to me, what is interesting now is to expand this and start using some other methods, right? Which some of them actually I only learned because I started working on this presentation, and I found some really interesting new methods that I had not seen before. Like the grep method, I had never used before.
Are you going to go back and rewrite all of your scripts now?
No, but I'm sure I have plenty of time to write new scripts.
Well, grep is kind of misnamed, right? I mean, it just removes null values from the result.
Well, it is another way of comparing, right? So it's used comparator and returns, and so it will return null elements as well if it doesn't match something.
I think grep if you don't pass it anything, grep removes null values. That's the way I use it. I use it with flatten and making sure you're not returning null values.
Let's see what actually grep does.
And that's why I say it's pretty misnamed, because
Satisfying and no, obviously it's false.
right.
Well, it is acting like the grep utility. It's the filter on the input.
But you're not providing a pattern.
Oh,
That's what find all is. Find all is more of a grep, really.
So what's the difference between grep and find all?
Grep just acts on Groovy truth, and find all you actually give it. You tell it what the truth is.
So you give it a comparator. So find all square brackets it would be exactly the same.
Yes, I think so. Yeah.
And you can pass the actually
Right.
closure here also.
Yeah, I've never done that.
But you
It doesn't
can
look
add
like
it
it's
says
on
it.
I'm sure you can actually.
Closure
Using
I
identity,
filter.
closure,
So if you just
filter.
scroll it.
So as you said, nulls are removed, right? Which is nice.
Well, yeah, because if you're using it by itself, it's just doing Groovy truth on all of your
Right.
elements. And null is going to be false.
Yeah.
But then, so it's zero if you have one of those.
And empty array collections.
So how do you use grep?
Basically, some of my data, I have a property, a list of objects with a property. Sometimes that property is null, and if you do flatten on that property, those nulls get included in the results. So, and also I have some bad data, so I'll have a list of 3 values, and the second one is null. So when you flatten all of that, you call grep, and it removes the null values, and then you can use that collection. You can sort.
So in your context, really, really useful. In my context, it would be catastrophic if I remove one of the null values in a
Right.
in a.
And again, it's not only null. You
field,
see,
right?
from example here, zeros, empty strings.
You
I'm
know,
wondering how
That's
many
why I think
zeros are
undefined results is there too, because it doesn't remove falsy values. It just removes the null values.
So that's what I should be using.
So find
probably,
results,
instead of
yeah.
grep. Yeah.
There you go. If we got something useful at tonight, it's how to
Yeah,
use
absolutely.
the find results and grep. All right. So here's a simple example that I've used actually now recently. How to control program flow with a list, right? So we have a switch statement here, right? And it takes, oops, and it takes as the switch case a list. And you can imagine where now you have a complex logic where you want to compare, three different things and decide on three different things how you're going to proceed. Right? This is really very cool because you can actually start setting up your cases here. And if you were trying to do this with if, then it would be total disaster, right? If you have different things, but it works really cool. So here's a kind of a fun example. We know the 3 strikes and you're out kind of thing, right? So here are the strikes, and depending on what we're going to pass in, we're going to get one of these use cases to. Let's see if this is going to work. Okay. So right now we're passing in where all 3 strikes are in effect, right? And you should print out you're out, right? On the other hand, if we so now, okay, this is a perfect guy. He doesn't have any strikes against him, right? You're awesome. And maybe another guy that has some true strikes. Not there yet, but watch out. Okay. So you can control the flow, the logic flow of your program with an entire array of true false cases. So you can, this I thought, I've used it recently in a complicated logic case.
It's
Really well.
interesting idea. It's just very unreadable.
Well,
Very what?
Unreadable.
Unreadable.
Nested
Yeah.
if statements is so much easier to read.
I'm not sure about that, but this is definitely very unreadable. You can
So-
comments here and follow them.
So you would, of course, not be passing in like this, right? You would have your actual,
When you pass, I understand,
Yeah.
but cases,
Yeah.
you have to be.
Well, wait a minute. This is almost like a rules engine.
It is, and in fact, I'm trying to remember now the author that when you create a table, when you had a complicated case, when we're trying to do complicated rules, you create a table essentially, right?
Yeah.
You put all your cases, and then you
Right.
say, you're going to be, in this row, in this column where those cases are. And that's you have some. So it's the same thing here. Basically, you can create a rules and you can execute based on those.
On the plus side, I'd be the only one who could debug it.
Job security.
Exactly.
I like that. And
That's why-
revenge,
that's why
job
we're
security,
here.
and if that fails, vengeance.
Yeah.
Right.
That's a twofer.
But you could say, in this case, you can make it really readable if you say like,
this is not unreadable part.
Right?
This
kind
part,
of like thing, you know.
yes, this part is fine readable, yes. But when you have a case,
Yeah.
so you should have actually the constant, define the constants for each of combinations with a meaningful
It's just an
name. You could, then it would be
Yeah.
readable.
Yeah,
Yeah, it just to show you that. Also, the other trick here, I don't know if you realize this, you want to actually
I
put
would
this
use the
in a list by itself, right? Because if we do not use this, so when I was writing this, the only thing that threw me off was actually, originally I was trying to do something like that. And that doesn't work because it uses every element on its own in this case, right? So you actually have to have a list of the exact case, right? So this one will not work. Right? So if we had, so let's say we're passing one now. Oh, I'm doing something. I keep trying to do the same things I do with the Groovy console. That is where I keep Control R, and that actually.
Oh, that refreshes the page and then you're hooked.
Yes. All right. So. So despite the fact that everything is true, it goes down to the default case, right? So it prints out not there yet, but watch out. Right? So these have to be created as the exact list that you're going to be testing for. And then it works.
So case takes the list instead of case
And create
value,
all of
case
those
value,
cases.
case value without breaks.
Okay, so now it does the correct. All right. Collections, again, pretty awesome for doing any kind of parsing of XML. A lot of our instruments write XML data out, and using the XML slarper in Groovy is pretty cool. Trying to parse this data. So it's just as simple as because when you, of course, parse the XML, it creates a list of the nodes, and you can access their. Let me see if I can actually. This is code in here. Actually, it's out as a. Record over here. So you see over here we have these set ID text values that are embedded. I have a little tool called XML Notepad, so you can throw in some XML and you can see the way the nodes are lined up. So I took a screenshot of that. So you can see these values QS1, QS8, QS9 that are here. All right, so we're going after finding, first of all of the nodes where the name is equal to set CD, right? So it goes through the nodes and it finds the set CD nodes, right?
The star is returning all of the nodes from the XML, right?
Yeah.
And turning into a collection base.
Thank you. So that's the from the parser over there, and then we collect, just doing some nice transformation so we can see it as and you see here also the join. You were asking about the join earlier, and concatenates as a string so that we can have it as this sort of comma separated list of values here. Okay, and there's a lot of tricks you can play with XML parser, but just having the ability to apply all those cool collection methods to those nodes is pretty used quite a bit. Here's another example. So this is from my imaging software that does image processing, and it defines these pipelines of in this type of text file. So at some point, I'm interested in understanding all the modules that are used by the imaging pipeline. So such as align, mask image, correct illumination, and so on. So the way that works is also through collections. And it's pretty simple. That's the nice thing about them. With a few modules you get, with a few lines of code, here I can get all of these information that I need. So I have actually this example file on GitHub right now. I don't know if you've ever tried to read directly from GitHub the content. It comes out with these strange looking. You have to hit on the raw button when you actually need to get GitHub to act as a file server type of thing. Otherwise, it will not give you the information. So we can read this file directly from GitHub. I think I may need to set up my Groovy proxy, but let me just try it for a minute. Yeah, no, I had it set up. So here is the modules that exist in this pipeline, right? And so you see this is a simple, text file, all of the imaging information. So what we're doing in this script is a couple simple things. First of all, we just read it in, and by reading these lines, we're actually creating a collection of the lines of the file, which is also pretty cool. A lot of things in Groovy, you can turn them into collections, and this is one of the most useful ones. So here we're using, again, the find index values. And the comparator here says, if the line contains this little sentinel thing called module num, right? So I'm looking for this kind of thing, because all of the modules, that first line of the module has it. So that pulls out just those lines. And then this is what we were talking about earlier, that you need to cast these index values into an int in order for it to work. But basically, we pull those lines out of the collection of lines on this column. And then, of course, we take the name of the module, which is the element 0. And then we apply a couple simple methods, such as the unique and sort. So we get a unique list of these modules sorted by name, and we bring it up. Right. So, with probably less than 10 lines of code, we have a nice way of parsing this file and identifying the imaging modules that are there. I'll try to get you guys out in the next 10 minutes.
Do you have any examples that use group by?
You know what? I don't have an example.
Okay. I just noticed on your list.
Yeah, it is a cool example, and I have used it, but I don't have an example. I wanted Howard to show you combinations. I don't know how many of you have used combinations. This is a pretty cool thing, right? So combinations. You will find all the possible combinations given to collections. It will create a new collection with all of the combinations. So, this is sort of a use case that I had. We have this, they're called assay plates in the lab, where basically there are little reaction vessels, each one of them, and we'll do whatever we want to do for testing each one of those little wells, and then we get a result out of it, right? So we had a set of results where these were labeled as, plate row 1, plate column 1. So rather than the saying A1, A2, it was 1, 1, 1, 2, and so on, right? But in order for using this with some of our software, we needed to have actually a so-called well ID column, which would look something like this. So how do you create something like that? Combinations came into play in this particular case, okay? So, let's see. So what I did here, by the way, what I was showing you was called a 96 well plate. It has 96 well positions, right? What we actually use, and I think I've used this prop before, they have said it, okay, is these kind of plates, okay? These are 1,536 wells, okay? Very high density. A human usually cannot pipette things in there because they're so fine. So, we have our robots that are delivering these things around, right? And they have a glass bottom because we put them on the microscopes, and then the microscope takes pictures of the cells that are sitting at the bottom. So if you hold it up, you can actually see it's clear. Right? So the alphanumeric codes go from A to AF. All right? So I create essentially, the row IDs here. And then here we use arrays because the columns go from 1 to 48. And, so when you do a combination, it's a 1536, right? So it's 20, 32 here, I believe, and 48, right? So the first thing we do is we create a combination. And basically, I took this and turned it into a list because this is not a list yet. This is just a string, right? So I'm splitting it to create a list. So here's one list with this. And then the other one is the column IDs that go from 1 to 48, except now I format them so that they have some extra zeros in front of them so they are nicely lined up, right?
So why you create this string with all these letters instead of just calculate that, create it
Well,
alphabetically?
it gets weird once it gets down here, right?
No, why? If you have again what is it, combinations, and you combine the whole alphabet with the empty string and then the whole alphabet,
Sure.
You will have all of them, and then you just cut as many as you need.
Well, aren't you clever?
Right. And then you can do it, use it for different sizes. Just you can make it so that it would work with different size. What are these called?
Subwards.
What?
Asset
Asset
place.
place. Is
This
there
looks,
only one size?
this looks like it's dead. I don't get. Do you get any
Yeah,
charging on
different
yours?
sizes. Yeah, yeah, then it would work with different
Thermal
sizes.
cycles, if I see the 96 plates, but then microscope.
I think maybe this was equipment. Or
Oh, now it's charging.
Yeah.
Okay.
Yeah, I think this was a little.
It wasn't okay.
Different areas.
Thank you.
No problem.
All right. So basically, once we have those combinations, right? First of all, we assert that they should be 1536, right? The size, and then you know, this is just some formatting to print them out. All right. So let's run it. I think it's just run.
Right,
Oh, no,
exactly.
it's actually still executing. So there we are.
I love it.
It created a list, right? My required alphanumeric things, and so it still has now the the alphanumeric as we saw it earlier, the row as a alphanumeric, the column as a numeric that's padded with zeros, and then the combination of the two. That I needed. All right. Here's another way I use this. I use collections quite a bit to create dynamic code. And I need to create, for example, a sequel. Sometimes, you know, you have end, and you need to know when to stop and so on. And so collections come in quite useful for that, because then you can join with end, or you can do this. So so this is from Jenkins. As some of you may know, that, you know, Hijack Jenkins do actually analytics and bioinformatics. And this is one of the utilities we have on it, where basically we use it to join CSV files together that have some common fields, right? So it's a join, it's a database join operation. So once you click build, it creates two H2 databases in memory. It uses the information we're passing from here to select the columns in which to join the data. And it's very dynamic here. As you see, once I select a particular file, it shows me the columns in there, and then I can match. So this file said metadata barcode, this one only had barcode, and I know that these are together, right? So we match it.
So you put the Groovy script inside of Jenkins as a project in order to execute and combine the two. Oh, cool. Okay.
Yeah. So you know, we use Groovy and Groovy scriptlets quite a bit. I use actually H2 as an embedded database. So Groovy instantiates in memory H2 databases to do database operations. It works pretty well, actually. Yeah. So I wanted to go into some more detail on this, but I don't think I'm going to do that. I'm going to skip that. Here's an easy example to see where, you know, a lot of us are working with JSON one way or another, and a collection can be turned into JSON, you know, almost by, you know, 2 lines of code. We have a collection here. Which it's a map. It has one of the values actually a range, right? And the rest of them are just you know, key value pairs. But you can very easily turn it into, come on, do that. I don't know why it fails. Let's just copy it. here's the created JSON from. So, you know, it nicely expanded the range, and you put it into the JSON elements here, to this array, and then everything else. So that's pretty useful if you were working with JSON.
Will you be sharing yours?
So yeah, no, I mean, of course, all of this. So once you were, just show again.
Harry updated the Meetup with the
Link
Yeah.
to his.
So this is my GitHub here, and here's, you know, the code and the what you call it? The if you click here, you open up the presentation. So it has all the other links.
It has all the links in there. Cool.
So that's already on
Yeah.
Meetup.
So I think I'm going to stop here. You know, I don't know, my little owl joined your owls, and hopefully we're all happy going home. Thank you for your input, your attention, and looking forward to the next presentation. Who's going to be you, right?
Well,
You wanna do it?
if it's done.
Okay. What's the deadline?
Well, I don't actually have one.
Yeah, well, like I said, I'm looking for speakers, anyone who's interested. Ralph said he would speak at this point.
I did. In fact, I started writing notes
Yeah?
on a
Okay.
possible talk that I wanted to talk to you about.
Cool.
All right, cool.
I don't know if I brought it. Oh, maybe it's in my notebook.
Okay, cool. Well, thank you.
All right, you're welcome.